everyone, and welcome back to Newton's Academy past paper review for grade 12. Today we'll be doing the physics topic of the Doppler effect, and we'll be attempting this question 6 that we see here. So starting off and reading the question tells us a sound source on a car produces sound waves of frequency 850 Hertz. A stationary observer, right, that's quite an important point, tells us that the observer has a velocity of 0, measures the emitted frequency using a detector which can measure a maximum frequency of 800 Hertz. So we see that the frequency measured by the detector which the observer holds, the frequency measured by that detector is less than the frequency actually emitted by the car. He then finds that the detector only registers a reading whilst the car is moving. So the car is moving. They have not told us whether it's moving towards the observer or away from the observer. However, based on the fact that there's a frequency change, we will be able to determine which direction the car is moving in. Question 6.1 asks us this very question. In fact, it asks, must the car move toward or away from the observer for the detector to register a reading? Explain the answer by referring to the frequency or the wavelength. So let's just look at this. We have our observer and we have our source, which is the car. Now, if the car is moving away from the observer, so if it's moving that way, then the sound waves emitted behind the source are now extended, whereas the sound waves emitted in front of the source are more compressed, meaning the wavelength behind the source, those wavelengths right between each wave, those wavelengths increase. And if wavelengths increase, that means the frequency decreases. So automatically, if the source is moving away from the observer, the wavelength should increase and the frequency should decrease. Or if we're referring to the frequency and not the wavelength, then we say when the source moves away from the observer, the frequency or the apparent frequency behind the source has now decreased. So that will always be a constant. As long as your source moves away, then your frequency will decrease. And if your source is moving toward your observer, then your frequency will increase. So that is a constant. So for 6.1, the answer will be away. And the reason would be that the apparent wavelength increases, and as a result, less waves reach the observer per unit time, which ultimately means that the frequency will decrease. Okay, looking at question 6.2, 6.2 asks us, calculate the minimum speed at which the car must move for the detector to register the maximum reading. And this is the maximum reading, 800 Hertz. Remember, that is the apparent frequency, and 850 is the frequency of the source. Take the speed of sound in air to be 340 meters per second. So first thing we do is we write down the formula for calculating the frequency due to the Doppler effect, and that is our apparent frequency is equal to the speed of sound in air plus minus the speed of the observer or the listener divided by the speed of sound in air plus minus the speed of the source, which in this case is our car. And all of that is multiplied by the frequency of the source. So in this case, we're given the speed of sound in air, we are given the frequency of the source, we are given the frequency of the that's measured, or the apparent frequency, and we want to solve for the speed of the observer, right? So the speed at which, or not the observer, the speed of the source, the minimum speed at which the car must move. So that is the speed here. We are not told or explicitly given the speed of the observer, but we are told that the observer is stationary. That means that this value here, velocity of observer, will be 0. So we can now go and substitute our values. The apparent frequency is 800 hertz. We have the speed of sound in air, which they gave us to be 340. We have the speed of sound in air once again. And now to determine whether this is a plus or minus, whether the velocity of the source is a positive or negative, we can simply draw the same diagram here and follow the convention. So we have the listener on the left, the source on the right. If the source moves away, velocity is positive. If the source moves towards the listener, velocity is negative. Same with the listener. If the listener moves towards the source, velocity of the listener is positive. If the listener moves away from the source, the velocity will be negative. But in this case, the listener or the observer is not moving at all, so its velocity is 0, and the source is moving away. Therefore, we will have a positive velocity of the source. And all of that is multiplied by 850 hertz. So we only have one unknown, and making that the subject of the formula, we get the velocity of the source or of the car to be 21.25 meters per second. The direction is away from the observer. Okay, so that gives us the minimum speed of the car for the detector to register the maximum frequency 800 hertz, because obviously if the source moves faster than that, the frequency will be lower than 800 hertz. Lastly, 6.3 asks us, state one use of the Doppler effect in medicine. Right? So this is a theoretical question. You simply memorize the uses from your textbook or from the list that your teacher gives you. So there's two primary uses of the Doppler effect in medicine. The one would be to measure and monitor the blood flow, meaning the flow of blood in your arteries or veins. That uses the principle of the Doppler effect, and it's used in a device called the Doppler flow meter. So the first use is monitoring blood flow. The second use would be to measure the heartbeat of a fetus. Those are the two primary uses of the Doppler effect. Okay, and that brings us to the end of this rather short question on the Doppler effect. Normally, they do always ask you to state the Doppler effect, so just be prepared for that. In this question, they didn't, but most questions on the Doppler effect will ask you to state the Doppler effect, so make sure you memorize that definition. All right, thank you for watching.